Hello friends, in this video I am going to discuss different problems and solutions related to the probability. So the first problem, at a college track meet, the 100-meter race has 10 contestants. The top 3 will receive points for their team. How many different permutations are there for the top 3 from the 10 contestants? Now here 9 is equal to 10 number of contestants and top 3 will receive the points. So here the position is important. So the different here we have to use permutations. So NPR, so 10P3. So factorial of 10 divided by 10 minus 3, that is 720. So the required answer is 720. So 720 different permutations are there. Now next problem. Out of a full pack of 52 cards, 2 cards may be drawn. Then how many ways are there? Clear? So n is equal to 52 total number of cards and we have to draw 2. So NCR ways are there. So 52 C2 ways are there. So total answer is 1326. Here the position is not important. So here we have to use combination. Okay. Next problem. Third problem. A number x is chosen at random from the numbers -4, -3, -2, -1, 0, 1, 2, 3, 4. What is the probability that x is less than equal to 2? What is the probability that x less than equal to 2? Okay, so mod x less than equal to 2, the answer is only these three. 1, 0, -1, because it is mod x, not only x. Clear? So if it is like that, if it is x less than 2, the answer will be 1, 2, 3, 4, 5, 6. 6 by 9. Okay. Now here is mod x, so the answer should be 1, 2, 3. So here it is 3 by 9. Okay. Next. A die is rolled and a coin is tossed. Find the probability that the die shows an odd number and the coin shows a head. So the sample space are, this is 1 head, 2 head, 3 head, 4 head, 5 head, 6 head. So the rolling a die 1 to 6 and tossing a coin, heads are there and tails are there. So find the probability that the die shows an odd numbers and the coin shows head. Odd numbers and coin shows head. So total number of favorable events 3, total number of events 12. So probability is 3 by 12, that is 0.25. Clear? Next. In a class there are 15 boys and 10 girls. 15 boys and 10 girls. 3 students are selected. So 3 students are selected at random. What is the probability that 1 girl and 2 boys are selected? Clear? So the combination may be 1 girl, 2 boys. Okay. 1 boys, 1 girl, 1 boys and 2 boys and a girl. So probability, so total number of students, say 25. Okay, so probability of getting girls means here 10 by 25 probability, boys 15 by 25 and then 14 by 25. So not 25. So first one 10 by 15 25, then one we have chosen 1 girl, so the remaining 2 boys are there, so 15 by 24. We have chosen 1 boy, so the answer is 14 by 23. Clear? First possible combination. Second, 1 boy we may select, so 1 boy means what? 15 by 25. Then we can select 1 girl, that is 10 by 24. Then we may select another boy, so 14 by 23. Clear? Or we may select first 1 boy, so 15 by 25. Then we may select another boy, so 14 by 24. Then we can select 1 girl, that is 10 by 23. Okay, so the required answer is 0.4565. Clear? So the required probability is 0.4565. Next, in a box there are 8 red, 7 blue and 6 green balls are there. 8 red, 7 blue and 6 green balls are there. One ball is picked at random. One ball is picked at random. What is the probability that it is neither red nor green? So neither red nor green. So it should be the blue. Okay. So total number of balls. So 21 balls are there. Okay. Okay, 21 balls are there, and out of 20 balls, 7 are blue. So the probability that it is neither red nor green means it is blue. So the probability is what? 7 by 21. So probability of neither red nor green means what? Probability of blue, that is 7 by 21. Okay. Next. Seventh one. 10% of a company's employees are BTech. Okay. 10% of company are BTech. 30% of the company's employees are MBA. 30% company employees are MBA. 3% of the company's employees are both BTech and MBA. So 3%. So that means BTech and MBA 3%. That is what? 0.03. Okay. Probability of BTech 10% means 0.1. Probability of MBA, it is 0.3. So these are given. Okay. So 10% of company's employees are BTech, 30% of the company employees are MBA, 3% of the company employees are both BTech and MBA. What is the probability that if select a BTech employee, given that she is also an MBA? Okay. So we have to identify probability of BTech given that he or she is from MBA. Okay, so conditional probability. So probability of BTech intersect MBA by probability of MBA. Clear? So BTech intersection MBA, that is nothing but 0.03, and probability implies 0.3. The answer is 0.1. Clear? Next, 8th problem. A hawker has a 0.65 chance of making a sale to each customer. Okay. So probability customer 1 is 0.65. If he enters 2 customers, C1 and C2. Clear? What is the probability that the hawker will make a sale to C1 or C2? Okay. So probability of C1, okay, probability of C1 or C2. So that means okay, so here probability of C1 to probability of C2. So here he success, here will not, and probability of C2 and probability of C1. Clear? So probability of C1 is 0.65. Probability of C1 bar is equal to 1 minus 0.65. probability of C2 bar is equal to what? 1 minus 0.65. So the answer is 0.65 into 1 minus 0.65 plus 0.65 into 1 minus 0.65. The final answer is 0.8775. Okay. Next. An MTech students applies for a lecturership in two colleges, C1 and C2. C1 and C2. The probability of her being selected in C1 and C2 is 0.85, 0.85 and 0.6 respectively. The probability of at least one her application being not accepted is 0.3. Okay, that means C1 complement union C2 complement. The probability of at least one her application being not accepted, at least means maybe rejection from C1, from C2 or both, is 0.30. What will be the probability that she will be selected in one of college? Okay, so we have to identify C1 union C2. Clear? So very simple. So here we have to have C1 plus C2 minus probability of C1 intersection C2. Okay, so what will be the probability that she will be selected in one of college? So either C1 or C2 or both. Clear? So here C1 plus C2, here we can write 1 minus C1 bar union C2 bar. Okay, so you can select C1 intersection C2. If you apply bar here, okay, so C1 probability of C1 intersection C2 is equal to 1 minus this one. Okay, now 1 minus probability of C1 intersection union C2. So here we are using De Morgan's theorem. Clear? So from this here it is okay. So probability of C1 is 0.85 and probability of C2. So probability of C2 is 0.60. Okay. Next, 1 minus C1 and probability of C1 bar union C2 bar, that is nothing but 0.30. Yeah. So 1 minus 0.30. So the actual answer is 0.75. So final answer is 0.75. Okay. Next problem. Problem number 10. A and B roll 2 dice 35 times and record their results as follows: 3, 5, 7, 10, 7, 7, 2, 5, 7, 9, 4, 3, 7, 8, 9, 7, 10, 11, 11, 12, 4, 2, 7, 8, 9, 3, 5, 6, 9, 2, 5, 7, 9, 11, 12. Clear? So 35 times 35 events are there. What is their empirical probability of getting 7? So out of 35 events, what is their empirical probability of getting 7? So probability of getting 7, so total 35 events are there. Out of 35, 7 appears 8 times. 7 appears 8 times. So what is the empirical probability? It is nothing but 0.2285. So empirical probability of getting 7 is 0.2285, because out of 35 number of trials times, 7 appeared 8 times. Okay, so number of favorable events are 8. Clear? Next, what is the theoretical probability of getting 7? But the theoretical probability is 6 by 36, that is 0.166. Here 6 is the number of favorable events and 36 is the number of total events. Clear? So this is nothing but our empirical probability, this is nothing but our classical probability. Okay, now already you know where you can use classical probability and where you can use empirical probability. We have seen in previous videos. Clear? Next, a market survey conducted in 3 cities to prefer for brand Sheetal soap. Clear? So there is one soap, there is a soap company, the name of the soap is Sheetal. Okay, the response are shown below in the form of contingency table. Clear? So first of all, I'm just drawing the contingency table. Okay, so this is our contingency table. Now in this particular using this particular contingency table, we can solve various type of problem. Okay, now for example, what is the probability that the customer prefers Sheetal brand and he or she was from Chennai? Clear? So what is the probability that customer preferred Sheetal brand? Yes. Sheetal, like Sheetal, yes, no, no opinion, O. Ranchi, R for Ranchi, K for Kolkata and C for Chennai. So Sheetal brand, yes, and he was from Chennai. So total number of events 275. Out of 275, Chennai 80%, total number of 80% are there who prefer Sheetal from Chennai. Okay, so the probability is what? 80 by 275. Clear? So if you solve this one, you can get to the probability is 0.2909. So the probability that the customer prefers Sheetal brand and he or she was from Chennai, and so that's why it is intersection from Chennai is 0.2909. Clear? Now what is the probability that, next, what is the probability that a customer was from Ranchi? Okay, so what is the probability that the customer was from Ranchi? So Ranchi, so total number of events 275, number of favorable events, so from Ranchi, so addition of all, so that is 85. So 85 by 275, so 85 by 275 means 0.3090. Clear? So the probability that customer was from Ranchi is 0.3090. Next, what is the probability that a customer was from Ranchi or she prefers Sheetal brand? Clear? So next problem, the customer was from Ranchi or means union, he or she prefer Sheetal, yes. So probability of R plus probability of Y minus probability of R intersection Y, because these two events Ranchi and Y, yes, these are overlapping event, it's not a disjoint event. So probability of Ranchi 85 by 275, probability of yes 170 by 275 minus Ranchi intersection U. So Ranchi intersection U means what? 60. So minus 60 by 275, The answer is 0.7091. Okay. Next. What is the probability that a customer did not prefer brand Sheetal given that he was from Kolkata? Clear? So we have to identify N by K. What is the probability that he doesn't like Sheetal given that he is from Kolkata? So it's a conditional probability. So it is N intersection K by probability of K. So probability of K is total number of customer from the Kolkata. So 80 by 275. Okay, and N intersection K. N intersection K means what? 40. So 40 by 275. Okay, so clearly you may write 40 by 275 divided by 80 by 275. That is, answer is 0.5. Okay, so not intersection Kolkata is 40, total number of events 275 divided by probability of Kolkata. So probability of Kolkata is 80 by 275. 80 by 275, the answer is 0.5. Okay. Next, what is the probability that a customer was from Ranchi given that he or she had no opinion about the brand Sheetal? So very simple, we have to write Ranchi and no opinion. So probability of R intersection O divided by probability of O. So probability of O means total opinion. Okay, no opinion, so it is 35. So 35 by 275. 35 by 275. And Ranchi intersection no opinion. It is 15. Okay, so 15 by 275. The answer is 0.4286. Okay. Next, what is the probability of drawing a jack or a 5 from a well shuffled full deck of cards? Okay. The second type of problem. What is the probability that drawing a jack? Probability of drawing a jack or a 5 from a well shuffled full deck. Actually, these are non-overlapping events, so we can write probability of J union probability of 5. Okay, so how many jacks are there? 4 by 52. And how many 5s are there? 4 by 52. The answer is 0.1338. Okay. Now, if the problem is like that, what is the probability of drawing a jack? What is the probability of drawing a jack and what is the probability of drawing a jack or a red card from a well shuffled full deck of cards? Now here, jack and red, these two are not independent, they are dependent. Overlapping is there. Clear? So probability of jack union probability of red minus probability of jack intersection red. So probability of jack is what? 4 by 52. Probability of red 26 by 52, because out of 52, 26 red cards are there, and 2 jacks are there which are red in color. So 2 by 52. So the final answer is 0.5384. Okay. Next, tossing a coin 2 times. Number 18. Tossing a coin 2 times. What is the probability of getting 2 heads in a row? So probability of fate and head. So probability of head. Okay, and means what? Probability of fate intersection head. So probability of fate and they are independent events. So probability of head into probability of hand. So probability of getting head is what? 0.5. Probability of getting another head 0.5. The answer is 0.25. Clear? Very simple. Next. Following contingency table shows the gender and player relationship. Okay. So following contingency table shows that gender and players relationship. Okay. Now it's a contingency table. So male, female, players yes, players no, total, clear. So it's nothing but a contingency table for the table. Now calculate the probabilities that a student is a player. Okay. A student is a player. So probability of player is what? 40. Yes. 40 by total number of events 160. That is 0.25. Second question: a student is a player given that C is a female. Clear? So female student is a player given that he is a female, C is a female. So player and female. So probability of player intersection female divided by probability of female. Probability of female is what? 80 by 160. Female and player, it is 20 by 160. That is 20 by 80. Okay, so 20 by 80 is equal to 0.25. And third, a student is a player given that he is male. Clear? So student is a player, he is for male. So probability of player male by probability of male. So 80 by 160, 20 by 160, answer is 0.25. Next question: are gender and player independent? Are gender and player independent? Since probability of player and female is equal to probability of player. So what is probability of player? Probability of player is what? 0.25. And probability of P by M, that is also 0.5. Clear? And probability of player and male is equal to probability of player. Okay, so 0.5 is equal to 0.25. Okay, so hence two variables gender and player are independent. So we can check, in this way you can check whether two attributes are independent or dependent. Clear? Next problem, question number 20. The odds against student 1 solving the statistical problem are 5:7. Okay, so statistical problem 1, it is 5:7. That means it is what? 7 by 5 plus 7, that is 7 by 12. And the odds in favor of student 2 solving the same statistical problem are 4:6. Okay, so 4:6. So it is what? 4 by 4 plus 6. Okay, so that means it is 4 by 10. So first question: determine the probability that neither solve the problem. Clear? Neither solve the problem means probability of S1 intersection into neither problem solve the problem means. Now apply De Morgan's theorem, intersection S2. Clear? That means they are independent events. So S1 intersection or into probability of S2, because they are independent event. So probability of S1 bar. So probability of S is 7 by 12. N1 1 minus 7 by 12 into probability of S2 bar. S2 bar is what? 4 by 10. That means 1 by 4 by 10. 1 minus 4 by 10. Sorry. So the answer is what? 0.25. Clear? Second question: determine the problem will be solved. So problem will be solved means what? Anyone can process. So S1 union S2, that means S1 can solve it, S2 can solve it, or both can solve it. So probability, so we can write probability of 1 minus probability of S1 union S2 bar. So 1 minus 0.25 because already you have solved it. Clear? So 0.75. Okay, so very simple. 3 alike bags B1, B2, B3 contains 4 white, 3 red balls, and 3 white and 7 red balls, and 2 white and 3 red balls respectively. A bag is chosen at random and a ball is drawn from it. If the ball is found to be white, what is the probability that bag B2 was selected? Okay, now here let the observed event that drawn ball is white be A. 3 identical bags are there, so the probability of drawing B1, B2 and B3 bags are PB1, PB2 and PB3. So 3 bags are there, B1, B2 and B3. Clear? So in B1, 4 white and 3 red balls are there, 4 white and 3 red balls are there. In B2, 3 white and 7 red balls are there, 3 white and 7 red balls are there. And B3, 2 white and 3 red balls are there, 2 white and 3 red balls are there. A bag is chosen at random and a ball is drawn from it. If the ball is found to be white, what is the probability that bag B2 was selected? So here we can use Bayes theorem. Bayes theorem. Clear? Now PE1. So here we have to apply Bayes theorem. Okay. Now you can, if you see the problem once again, 3 alike bags are there, B1, B2, B3. So probability of selecting first bag 1 by 3 because 3 blacks are there and 3 are identical. So probability of selecting B1 is 1 by 3, probability of selecting B2 is 1 by 3, probability of selecting B3 1 by 3. So these are nothing but our prior probability. Clear? Now in B1, 4 white, 3 red balls are there. So probability of getting white ball from bag 1 is what? 4 by 7. Okay. So total number of white 4, total ball 7. So 4 by 7. Here from 3 by 10. So 7 plus 3, 3 by 10. And probability of selecting white ball from bag 3 is what? 2 by 5 because 2 white balls are there and total 5 balls are there. So here it is 2 by 5. Now the question is, what is the probability that bag if the ball is found to be white? Okay, so probability of getting white is, so A is getting white ball, so probability of getting white is summation of this, so that is 0.4238. Clear? And if the ball is found to be white, what is the probability that bag B2 was selected? B1, B2, B3 are selected. Okay, so Bayes theorem, so this by this. Clear? So the answer is 0.4492. This by this number 0.2359. This by this is 0.3145. So if the ball is white, what is the probability that B1 is selected? So answer is 0.4492. So if the ball is white, what is the probability that getting probability that the bag B2 was selected? So 0.2359. And what is the probability that bag B3 was selected? That is 0.3145. So these are nothing but posterior probability. Clear? And these are the end of this particular video.